Pascal triangle is a triangular array of binomial coefficient. It was formed and named after French mathematician Pascal, Blaise Pascal. It is a tricky triangle.
It was named after Blaise Pascal. Blaise Pascal was a French mathematician, an inventor, and a great physicist.
Pascal's triangle is also known as a tricky triangle because it constitutes of many tricks of maths. For example, Fibonacci series, algebraic expressions and hockey series, etc.
The first property of Pascal triangle is sum property. Here we assume the numbers left to the 1 to be 0. Now if we see that 0 plus 1 is 1, 1 plus 1 is 2 and 1 plus 1 is 1. Again, in the next row we will see that 0 plus 1 is 1, 1 plus 2 is 3, 2 plus 1 is 3 and so on. The second property is the hockey stick, in which we will see that the sum of 1 plus 2 is 3. And if we see here also 1 plus 2 is 3. The second property.
Next property is magic of 11. As we can see, 11 raised to power 0 is 1, 11 raised to power 1 is 11, 11 raised to power 2 is 1 to 1, 11 raised to power 3 is 1 3 3 1, 11 raised to power 4 is 1 4 6 4 1 and so on.
Now we can also see that the sum of rows is in the form of exponents. Here a and b are equal to 1. In the first row, a plus b whole square 0 is equal to 1. In second row, a plus b whole raised to power 1 is 1 plus 1, a and b. In the third row, it is a plus b whole square is equal to a square plus 2ab plus b square, where a square is 1, 2ab 2 into a, which is 1, and b is also 1. 2 into 1 plus 1 is 2. Now b square, 1 square is 1. In the same way, the whole triangle is made up of algebraic identities.
Now, the next property is the summation property. As you can see that in this triangle, the first row, its sum is 1. In the second row, the sum is 1 plus 1, which is equals to 2. And 2 is also the double of first row. In this way, the triangle continues. This shows that each line of the triangle is double the sum of the previous line.
The next property of Pascal's triangle is Fibonacci series. In Fibonacci series, the first two numbers are 1 and each number thereafter is the sum of the previous two numbers. So here through this Pascal's triangle, we have drawn some lines which are from the topmost left corner of the hexagon. These cut one or two numbers of each hexagon, in which when summed up represent the Fibonacci series. For example, the first line cuts the number 1, which represents the first number of the Fibonacci series. The second line cuts the number 1, which represents the second number of the Fibonacci series. The third line cuts the number 1 plus 1, that is 2, which represents the third number of the Fibonacci series, and so on.
The next property of the triangle is the square and triangular numbers. So as we can see, the diagonals from the second row of the triangle represent the square and triangular numbers. For example, 1 plus 3 equals to 4. The 4 is the square of 2. 3 plus 6 is 9 and 9 is the square of 3. 6 plus 10 is 16 and 16 is the square of 4 and so on. And the next we have is triangular numbers. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10 and 10 plus 5 is 15 and so on.